Hello, welcome. Let's try to solve another Leetcode problem. 560 Subarray Sum Equals K. So we are giving an array nums and we are also giving an integer k. We're gonna return the total number of subarrays whose sum equals to k. And we should know that subarray is a contiguous non-empty sequence of elements within an array. So it means it must be contiguous. So for example, 1, 1, it is one subarray whose sum is equals to k equal to 2, and this 1, 1 also equal to 2. So in total there will be 2 subarrays meet the conditions. Yeah. So if the problem is a contiguous subarray and we're gonna calculate the sum of subarrays, basically we need to use prefix sum. Yeah. So for example, for this first example, nums equal to 1, 1, 1 and k is 2. Yeah. If we calculate a prefix sum, it's gonna be something like this. So we're gonna prepare a padding with 0, and the prefix sum would be 1, 2, and 3. Yeah. So after calculating the prefix sum, maybe you think we're gonna use 2 for loops. Yeah, because after using 2 for loops, basically it's like a brute force. But this is O(n) squared. That is not possible because n is 2 times 10 to the power of 4. So this means we're gonna use O(n) to solve the problem. But how can we use O(n)? We can use the sum2 method, toSum method. So the toSum method means if x plus y equal to the sum of them, maybe s. Yeah. But currently, currently this k equals to 2. Yeah. So this k equals to 2. So for example, if the prefix sum, the number inside of prefix sum is n, so this means this n minus a number. For example, the current number is x. So for example, if the current number is x, so this current number means here. So for example, here we have a number, but here is the prefix sum. It means this is 3 minus 1, it is 2. So this means this 1, 1. Yeah. But for example, this number is 1, 1 is x, and this number is n. N is the prefix sum, x is another prefix sum. So if the number n minus x equals to k, it means we've already found an answer. Yeah. And basically we need to find this kind of formula. And now for this x, if we find a number n, we need to know how many numbers of x. But how can we record that? We can use a dictionary to record it. So we're going to use a counter. So yeah, let me just prepare a counter, d as the dictionary as a counter. Yeah, and then we need to prepare a prefix sum. It's going to be list accumulate. So inside of the accumulator, it's going to be nums and initial. Gonna be starting from 0. Yeah. So after calculating that, we just need to loop through the prefix sum. So we need to check n minus k. Yeah, because n minus x equals to k, and we can get that. It means if we want to calculate x, so n minus k should equal to x. X is this number. We just need to know how many numbers of this number. So for example, this is x, this is 1. Yeah. So we're gonna prepare an answer n minus k. Answer should equal to n minus k. And if answers inside the counter, it means yeah, we can get the result would plus equal to that answer, the answer. And otherwise this d with this number n would plus equal to 1. Yeah. So as you can see that this is exactly like the toSum structure. Yeah. First of all, we're gonna check the difference. That is the answer. Yeah. So if this answer equal to n minus k, if it is inside of the dictionary, so we're gonna plus how many answers? Maybe 3 or maybe 4. So result would plus this number. And then we're gonna prepare this number. Maybe before it have 5 numbers, now this dn should plus 1. Maybe it's gonna have more numbers. So after that, we're gonna return the result. So the result would be starting from 0. Yeah. So here we have a result. Yeah, why this method is better? Because we've already know the two-sum structures, and it's very easy to understand the two-sum structures. So, for example, for the two-sum structures, while looping through for this for loop, we're gonna check it one by one. So for 0, we're gonna set 0 as 1, and for the 1, we're gonna set 1 as 1. Yeah. So what's the meaning of that? So this means there's only one. There's only one number. Yeah, there's only one number whose prefix sum equals to 1, and there's only one number whose prefix sum equals to 0. Now we are going to get this 2. Yeah, so for this number 2, so we're gonna use this 2 minus k. 2 minus k equals to 2, so it is 0. So for 0, we have one number of 0, so it means it's gonna result 0 plus this number, it's gonna be 0. So after that, dn should plus equal to 1, and for this 2, it's gonna be plus equal to 1. 2 will be here, 2 to 1. And next, for this number, last number 3, so the answer would be equal to 3 minus 2, it is 1. So how many ones? It is 1. So the result would still plus another 1. It's going to be 2. Yeah. But for example, if this number 0 is 10, we have 10 zeros. For 1, we have 11. We have 11 ones. What's going to happen? Yeah. So the answer would be, for example, if we have a number 2, we're going to check how many ones. There are 10. So it's going to be result plus 10, 0 plus 10. And then, while we are setting this 3 equal to 1, but 3 minus 1, there are 11 ones. So it's going to be 10 plus 11. So the result would be 21. Yeah, because it is always dependent on the prefix sum array. Maybe it is like this. So for example, it is 0, 1, maybe 0, 1. Yeah, there are a lot of 0 ones. And then the counter would count 0 as 10 times, 1 as 11 times. So while we meet a number 2, I mean here a lot of 0 ones. While we meet a number of 2, yeah, so this means this 2 minus 0 becomes 2, 2 minus this 0 becomes 2, 2 minus this. But we don't need to use the brute force to do that. Everything has already been recorded in the counter in our dictionary. Yeah, so this is why. Yeah, so this is why we can use on time to solve the problem. Yeah. Now let me submit it to check if it works. Yeah, as you can see, it works and it's pretty fast. Thank you for watching. See you next time.